life is over. I don't know how I'm doing math, but I'll try.
Well, this should be interesting. We start the day with complaints and disdain for something graphing. And the Three Stooges are already going,
No, I didn't. It was bad.
that's all right. You all keep going. We can have food on Monday. You'll have 4 days to figure out what you're doing. We did all these, right? Okay. I might come back to this. Not sure yet. But let's go to example 3, and we may or may not come back. In this space. Come on, Frank, wake up.
Yeah, no, I'm gonna bring 3 donuts for us 3, and then Werther's Originals. You guys can all have carrots. We'll bring carrots. We'll bring a bag of just one. Get some baby carrot. A single baby carrot.
Remind me, if we have a rational function, A, I want to factor whatever I can, just in case we have a hole. We will see that today. B, there's 4 pieces to it. Remind me, zeros of the denominator do what? Vertical asymptotes. Zeros of the denominator, because if I set this equal to 0 and cross multiply, I'm going to get 0 equals numerator. So, zeros of numerator make what? If I plug 0 in for x, all of this stuff becomes 0, and I just get my constants at the end, the y-intercept, also called function of 0. And we covered the rules. The rules as to whether I get a horizontal or oblique asymptote, and it sounds like this is where we were a little iffy whether we saw it in Algebra 2 or not, is no. I said green. I ain't green. Frank, young crack or something. There we go. So, if n is less than m, degree on the numerator is smaller, then when I try to take x to a small number divided by x to a bigger number, it goes in there 0 times. So I will have a horizontal asymptote at y equals 0. If they're the exact same, well then, if I have a x to the third over b x to the third, when I divide, x to the thirds cancel out, I'm just going to get a over b. So horizontal asymptote will be y equals a over b, my leading coefficients. So it sounds like we've seen that before. What we didn't see was, or some of us didn't see, is if my numerator is bigger, then I'm going to have an oblique asymptote instead, where I have to divide and ignore the remainder. A difference between this curriculum and the new book. Another reason that I went back to these notes for this semester, it's more familiar, but the new book does expect that you have seen a lot of stuff, because you should have. It's Algebra 2. The new book will go directly to parabolic asymptotes. I can divide x to the fourth by x squared and get x squared, right?
Yeah.
So it is entirely possible that you could get a parabolic asymptote and then a vertical asymptote, and your graph would look like this.
I really hate that. I'm a pass.
Okay? Could you divide and get a quadratic?
Yeah.
Could you graph that quadratic?
Yeah.
Could you then find your x and y intercepts, plot a couple other points? Okay, that's it. That's what it is. It's not hard. It's just, it's so unfamiliar because it sounds like we haven't even seen a linear oblique, much less parabolic. So, just letting you know that is a thing that exists. Going back to my old notes, it will not be anything that we encounter. And just let you know that is a thing that exists. The other book does have it. It's the same process. It's just uglier. Okay? So, if you look at those four pieces over and over and over, let's start graphing. What was the very first thing that I always do when I run across a rational expression? Factor, factor, friggin' factor. If I take out a 3, I'm left with x squared minus 1, which is itself x plus 1, x minus 1. This is difference of squares, x plus 3, x minus 3. We got enough experience that we can go straight to that numerator without first taking out a 3 and then going to a second stage? I hope. Like, we don't need the middleman of 3 times x squared minus 1. So, I read it out like this, and I do want both because we have different features. Denominator. I've got vertical asymptotes.
Wow.
Was that a sneeze, or did someone just get kicked in the tenders?
A little bit of both.
Um, okay, x equals negative 3 and x equals 3 are my vertical asymptotes. My x-intercepts are going to be at plus or minus 1. From my numerator zeros. If I plug in a 0, function of 0 is 1/3. So I know I'm going to have a y-intercept at 1/3. And then for horizontal or oblique, I look at my leading terms and their degrees. They're the same, so I will have a horizontal asymptote at y equals 3. Okay, it's those four pieces. Monday, we went through the how and the why of these pieces happening. I plug in a 0 for x to get a y-intercept. When I do that, the only thing that's going to be left is the constants at the ends of the numerator and denominator. If I plug in a 0 for y and try to solve, I'm always going to get 0 equals numerator and solve that. So zeros of numerator make my x-intercepts. We're just shorthanding the how and the why because we've done them enough times, or should have. The rules about my horizontal or oblique asymptotes. Basically, I always divide, right? I'm always taking leading term divided by leading term. If I take 3x divided by 3x squared, it goes in there 0 times. I have a asymptote at y equals 0. In this case, if I take 3x squared divided by x squared, the x squareds will cancel. I will get 3 over 1. I'm always dividing. It's just what the result is changes what my asymptote looks like. If I've got those 3 dots right there, you got to guess what this thing looks like without staring at the calculator? They like to alternate those different sectors, right? So I'm looking like it's going to be a downward U shape here, which means it's probably going to have the swooshes up there. To be sure about that, now I'm going to go into my calculator and I'm going to find a couple other points. Okay, looks like Bella already got that out, so if you would please, tell me a couple other points, like at -5 and -4. Okay, so -5, 4.5, so about meow. -4, 5.5? Question mark? Okay, so 6 and some change. If that's it, like you just find those points, would I see how far out of that little elbow, that armpit, how far out my curve is going to be? Okay. Connect the dots good enough. And these things love symmetry, so I'm betting I have a positive 4, 4.5. Or sorry, a positive 4, 6 point whatever you said. I'm betting there's a positive 5, 4.5. So I'll connect those dots to get my swooshes. And then my x and y intercepts are all in kind of clustered in that area. I'm not really sure how sharply it goes down or if it kind of widens out. So maybe I should also know at plus or minus 2 what those values are, just to make sure the curve is correct. Okay, so about here and about here. Connect the dots. We're good to go. So we're able to get kind of the framework or the scaffolding of the graph from the function, but I am going to have to still go old school by table to flesh it out, okay? All right. Why do I keep hearing screaming? Oh, well, I zoomed in over here. I forgot this part. The asymptotes, remember that was x equals plus or minus 3 and y equals 3. The domain, if I'm not allowed to be plus or minus 3, negative infinity to -3, can't touch us. But then the graph still existed from -3 to 3, can't touch that. And 3 to infinity. Now, it doesn't say how to state the domain. Would you rather do the interval notation or all x's such that x does not equal plus or minus 3 where x is an element of the reals? Like, in math, we tend to gravitate towards the interval notation Because it literally just looks like a line with that union on the asymptotes. Like, I'm able to match my domain up with that line. So, the first one's easy peasy. Let's do 3B. Do 3B. Oh, and if you have any notebooks and chapter 1 packets and stuff, especially notebooks, hand those in at the end of class today. I'm going to get through the notebooks second hour unless someone interrupts me, and then I will be very mad at them. Okay. I want to get through the notebooks because I got to do a grade-a-thon this weekend.
My tab's heavier for one. And then that one will come in.
You should have the chapter 1 packet in, but I'm saying for anyone who has their stuff also in a notebook, I need that. Okay. I will do the notebooks first. The packets, I'll probably end up bringing those home this weekend, and yeah.
80% sure after I move it.
Okay, factor what's there. Break it apart and look at those 4 pieces. Numerator, denominator, constants, leading terms. What? Maybe. No, there doesn't have to be a hole. It's a solution in the system between those 2 asymptotes. Yeah.
Oh, maybe not. That's not what this graph, so. I don't know, I guess.
That's not possible.
Okay. We all get where the horizontal asymptote's 1/5, right? Degrees are the same, leading coefficient over leading coefficient. So that horizontal asymptote says, thou shalt not have a y value of 1/5. I plug it in, and I prove, yeah, 1/5 don't work. And that's why, no, it will not go through that asymptote. If I ever do this, if I ever have an asymptote, and I set it equal to the function, and I get a solution, sometimes that happens. If there's a solution to that equation, then it will be able to pass through the asymptote. That is opening the shield in one little spot. Okay? So, yeah, like, if for some reason this ended up -20 equals -20 at the end, then I plugged this in and for some reason it worked. All right, well, I guess we had to go through the asymptote. You know, it's like when you try that one thing on your parents, you ask if I can get away with this, and they just say, yeah, okay. And you never expected it to work. Sometimes you get away with it. It's got to be the solution between them. And that's where we just got to graph it for now. The proof of why that is, later. Okay. Right now, we're just saying it is possible. Double check your points. Y'all, since we looked at the graph, we've got our x and y intercepts, and they're so tight, so close up against those asymptotes, I do not feel it worthwhile to do any other points. I'm just going to be very careful about when I graph this, trying to stay above the x-axis and then cross. Trying to cross and then stay above the x-axis. And there are times where we're going to graph those and it's not going to show us parts of these. Someone's calculator might have just shown them this. Or not even that. Like, okay, depends on how many pixels you got. Some calculators will only show you this. Okay? I did a quick run through Walmart errands this morning and picked some stuff up. I checked through the calculator aisle and got the TI-83, the same calculator I used in 1999. Still $100. The 84 CEs, those are like 150 right now, 160. Like, they own the educational market. If you are willing to learn how to use a different operating system, getting the Casios, the Casio graphing calculators, is going to be far superior. I genuinely believe they're better than the TIs. It's just these are what we got because that's what most educational catalogs and vendors and everyone use. Ready? Whee! Go! Go! I put a squared on both of them. I got a rough idea of what it's going to do, but figure it out. I'm pretty sure.
What did you do?
I graphed it.
What did you do how did you get vertical asymptote?
Solve the denominator. Set the denominator equal to 0. They're imaginary. I want you to graph your imaginary asymptotes.
I'll do it. Watch me do it.
I think, right? Okay. I said I got a pretty good idea of it. I know I can find those 3 features, but I would want to plug it into a calculator to double check. I didn't put a question mark next to it.
It's okay.
Right? When you go factor, to find the zeros of numerator and denominator, denominator does not have real zeros. Since there are no real zeros to the denominator, we saw this on one of our first examples yesterday, Monday. There's nothing real that's going to break my rules. There's nothing real that has to be excluded from the domain, so that means there's no vertical asymptotes. Okay? I got rules. It's just there's no one real coming to that party that's going to break them. So
What would you delete?
I'll roll numbers. Everybody's allowed to this party. Apparently they're going to get weird, but they're allowed to the party. You can still find your y-intercept. You still find your x-intercepts. Make sure you label them as plus or minus root of 6, not just 2.2 something, whatever it is. And your horizontal asymptote is still 1. Okay. Okay. The oblique asymptotes, like I said, we're going to divide. We're just going to ignore the remainder, and whatever that quotient is, that is my oblique asymptote. They only do this when numerator is greater than denominator. Something else we have to look out for is holes. This is another reason that we're always factoring, because sometimes you're going to get like quadratic over quadratic. You factor them, one of those factors cancels. You're still going to see this graph. This graph is still going to exist. It's just going to have a hole back here at x equals a. Okay? Remember when you're graphing these, though, the calculator will not show the hole. It'll look like it's continuous through that point until you trace or table evaluate to that specific spot, and then it's not going to give you anything. So, determine asymptotes, intercepts, graph the thing, blah, blah, blah. Okay. So, stage 1. Factor, friggin' factor. I've got a 2x cubed over a x plus 4, x minus 4. 3? What? Ah, crap. So it's a basic arithmetic we do wrong. X minus 3. I was so hung up on, oh no, I didn't make that blue. There we go. 2x cubed, blue. Now if I do this, yes. If I look at my zeros of the denominator, I'm going to have vertical asymptotes at negative 4, 1, 2, 3, 4. At positive 3. I'm going to have a x-intercept where? Zeros of my numerator. Right? If I set 2x cubed equal to 0, I get 0. So y-intercept. Go. 0 over negative 12 or 0. If you needed to put a 0 here like that. Okay. So it's almost like we were already there. Weird. And then I look at my degrees. The degree of the numerator is greater than. So I will divide. I'm going to show you two different things here, just to be safe. If I take 2x cubed, 0x squared, 0x plus 0, right? If you were going to get how much money did I make this summer, and I get paid in one lump sum, if it was $2,000, you'd be pretty mad if you just got a check that said 2. So, x squared plus x minus 12. We have to decide what it means.
Are they always going to be lines?
Ours are going to be lines in the ones we encounter, yes. If I take x cubed divided by x squared, I get just x. 2x. 2x times the stuff, I get 2x cubed, 2x squared minus 24x. Change signs. Getting negative 2x squared plus 24x. Drop it like it's hot. Go again. Negative 2x squared divided by x squared is negative 2. Negative 2 times the stuff. It's negative 2x squared minus 2x plus 24. Change my signs. I do get a remainder. But I'm just going to ignore it. I have to get a remainder. Because if the remainder was 0, that means it was a factor. If it was a factor, I could have canceled it and made a whole instead. Okay, so I'm just going to ignore the remainder part. This is my oblique asymptote. Y equals 2x minus 2. So I go to negative 2. Slope is up 2 over 1, up 2 over 1, up 2 over 1. Now, do you see how there's like a little wedge down here missing? Like it's going to vertical asymptote this way, oblique asymptote that way. Just so I can see the rest of my graph, I'm going to change my scale to go by 2 so I can see the entirety of it. No, not you. You. There we go. I'm going to make mine go by 2, so I'm just going to go here. And then up 2 over 1, up 2 over 1, up 2 over 1. That's why. I wanted to see that wedge down there. I wanted to see that other sector. Okay? Now, we all have this division written on our paper. I want to, because someone's going to ask this, could I do instead x cubed, x squared, x to the first, constant? Could I just do synthetic division twice with the 2 linear factors? But remember, it's not going to go in there evenly. I am going to get remainders. So I just want to see what this does if I use negative 4. So negative 8, 32, 32, negative 144, 128. I'm going to go again with positive 3, getting 6, negative 2, negative 6, 26, what's that, 30, 60, 78, negative 50. Okay. Remember, we were normally when we stack our division like this is a 0, and so I don't have this column at all. When I finish this one, this column should come out as a 0. normally when we're finding zeros. I ignore the last pair of them because all of this is remainder. I just took x cubed and divided it by x squared, or two linears, separately. I should be eliminating two columns or 2 degrees of that polynomial. Don't I still get 2x minus 2? Okay, so I'm showing you this because most of us would say synthetic division is faster. But you have to be smarter about it. You have to remember that my remainder gets ignored, but my remainder is still going to stack the more of these I'm doing. You got to be smarter, okay? Also, you have to be very, very careful about if you have a denominator on my zeros, that you're also dividing down here. So, I have x and y intercept. I've got vertical asymptotes. We now have an oblique asymptote. But I don't know what this graph does. Does it go down in that armpit and this one and go through? Or does it come down into this armpit and back up, stay here and here? Okay, so we do still need our calculator to check. And you say, how could I possibly go through an asymptote like that? Well, if that asymptote is 2x plus 2, set it equal to 2x cubed over x squared minus x minus 12. There is a solution to this equation. That asymptote will intersect with this graph. That's how I'm able to go through the asymptote. Yeah. Because you need your window to be bigger. Make your y maximum and minimum like 30. Literally is the solution in that system. If I cross multiply here, I get 2x cubed. That's 2x cubed minus 2x squared minus 12x. Nope, 24x. 2x squared, negative 2x, negative 24. So I get 2x cubed is 2x cubed gone minus 26x minus 24. Add 24, divide by 26. When x is 12/13, it will cross that asymptote. Because there's a solution between the asymptote and the function as a system, it will go through the shield. Okay? You all saw graphs go through horizontal asymptotes in Algebra 2, right? Okay. Now, was it that's because there's a solution in the system, or was it, yeah, sometimes that happens? Okay. There's a reason for it. Yeah. There is a reason for it. So I will need some more points. Hopefully you got your table in front of you and you can get those points. But you have to be careful about where you stretch this thing. Would I need a scale of 3 or 4 to actually see those ends? How high up are those in that armpit there? Like if I'm at x equals 5. 5 what? Okay, so I would be able to see it on a scale of 2. You will have to go to your, you can't just wing it, okay? That's what I'm getting at here. You need to see how far into those armpits this is going. Is it going to be really narrow like this? Or is it going to be more swooshy like that? You have to see how far into that corner your graph goes, and you only do that by graph by table. You ain't getting past it any other way. You're going to need some more points to make sure that you have the correct curvature there. So, same stuff we were dealing with. I'm going to have factor, find your vertical asymptotes, find your x and y intercepts, but then you're going to have to divide to find the oblique asymptote, and you're going to have to put a couple more points on there to make sure your graph is decent. And again, the domain is all those unions excluding your vertical asymptotes. This one is nice because it's just a quadratic over a linear. Nine fourths, 12, 21, 21 fourths. If you want your x-intercepts for this one, because the numerator is not factorable, you need to write your x-intercepts by quadratic formula or complete the square. And no, you cannot just write the decimal equivalent of it. So what's that, like 4.6 over 2, 2.3, negative 1.5 plus or minus 2.3. This is like 0.8-ish. And negative 3, 4.3-ish. Right? Because is this 2 point... 2.3-ish, 3.8. There we go. Okay. You do still have y-intercept. But your horizontal is not horizontal, it's oblique. Come on, you. And we're halfway through the semester now. Should be readily apparent there's a reason that we need a minimum of a C in Algebra 2 to come up to pre-calc. To just casually find your x-intercepts, you're going to have to solve by quadratic formula or complete the square, because that's how you solve those things. We'll rewind about 5 years or so. There was a teacher we shall not name who only was allowed to have Algebra 2 for 1 year, who had group tests. Everyone took their tests in groups, and everyone in that group got the same grade.
I feel like it's really unfair, but really nice. If you have one really smart person.
Uh-huh. There was not one person from that teacher who came up to pre-calc with a grade less than 95. They didn't know how to Algebra 2. They also didn't get through the last third of the curriculum. Can you imagine how those kids did coming up to pre-calc?
Bet you can tell us.
Worst performing that I've seen in 15 years. Okay. We have to know how to do Algebra 2. Every single skill that I just put up there, you did in Algebra 2. It's just we're putting it all together. It's kind of like a little kid knows how to make a peanut butter and jelly sandwich. They can follow directions and move food around. Okay, now go work at Quiznos. I'm pretty sure my 5-year-old can't go work at Quiznos. It's a better version of Subway. No, they had one in Rapid until it closed down a couple of years ago.
It was good.
Yep. They do toasted sandwiches. All of their stuff is toasted. Like that's where Subway got the idea. So, okay. Before we start roasting each other about food opinions, are you able to get those asymptotes?
Yeah.
Whether you're happy about it or not, can you get those x-intercepts? Okay. Now, my x and y intercepts are very close to the asymptotes, but you still have to see how far into that armpit does the graph go. So I would go to my table and double check at -1, -2, -3, -5, and so on. What values am I looking at? So, someone hit me up with the table. Let's go back to -6. Okay, so here's 1, 2, 3, 4, 5, 6, 7.5, -5. So I've got enough to curl along the asymptote and then just head down. Go to -3, -2, -1. -3, -3. You know what? If I had -3, -3, do you see how far into that corner your graph is going? Good enough. Whoop. And then it'll just curl along the asymptote. So maybe you only needed 2 extra points instead of a whole bunch. Show me thumbs. Not whether you like it. Do you get it? Can you do it? Are we a little bit sketchy, especially when things aren't factor nice? Or, buddy, I'm so lost. Okay, again, I'm just wondering if we needed another round with it, but yeah, we need another round. Let's go. 4B. All right.
Sorry to interrupt.
I want a little bit.
There's things about my students I don't want to know. How do you know Maddie isn't secretly 22 years old coming back for a GED or something? Maybe she just got served for jury duty.
Whoa. Well, I know her brother, so I'm like 89%.
Why does that look like that when the paper does not even close?
I bet we used a... You did x to the negative first.
Oh, okay. What?
Which is right next to squared.
Yep.
Just hit the wrong button, that's all. It is not. -1, so +4 is going to be 3, so it's going to be... So 5, 3 has... Yep, no. We'll show it all because this is going to matter. Square 3 is like 1.7-ish, so 3.7-ish. 2 minus 0.3-ish.
Is it half the finish
The synthetic. If you know you're ignoring the remainder,
then you don't have it?
honestly, there's times where I said that on my keys. Right?
I didn't do that, but I definitely
Like, you know that you're going to ignore the remainder. So, yeah, by all means, if you don't want to finish that part off,
we don't do more math than that.
work smarter, not harder, right?
So wait, what you didn't do was
If you do it by long or synthetic division, you will have the same thing.
so if I have
The coefficient on this one's bigger.
No, the degree.
No, I know what I'm saying. If I do 2x,
Yeah.
what do I multiply that would cancel out?
1/2 x. This is why I make y'all work with fractions. Sometimes math gets nasty. Remember, if I divided my synthetic 0 by 2, I need to divide my answer by 2.
but I didn't take anything out. That makes no sense.
Remember that this right here says x minus 3/2. It wasn't x minus 3/2.
Oh.
It was 2x minus 3. So if I divided this by 2, that means that my answer is twice as big as it should be. I need to cut that in half as well. Okay. It's still the same stuff that we were just doing. It's just it got uglier. Now all of a sudden I have to do either long or synthetic division where I end up with fractions. Now all of a sudden I have to do quadratic formula or complete the square to find my x-intercepts. It's not that I don't know how to do this stuff, it's I have to do all the stuff at the same time. It's a difference between I can play soccer in high school and I'm good at it and maybe I can even go to college and do this and get money because college is expensive, versus the little kids soccer meets that are always out here where it's just a bunch of little kids chasing the same ball. Who here did the little kid soccer thing? Right? It's not actually soccer. It's just like 20 kids chasing a ball at the same time. It's more like a co-op fetch.
The saddest thing is that
That's why I don't coach anymore.
but it's okay because then you get to yell at adults and you don't get yelled at. So.
I got rid of a whole lot of stress in my life when I stopped coaching and started doing game club instead.
U14, the parents will be all calm and stuff, but like the U8 games are like.
Yeah. Parents get pretty raw whenever it's kids sports. I just find some better meaning in your life. You don't have to live vicariously through your 12-year-old in Pee-wee soccer or something. Okay. I got the work up there. Are we getting to it? Now, x squared minus 4x plus 1 is clear. X squared minus 4x plus 1 over 2x minus. Okay. Now, a good way to determine if you found your asymptote correctly. I showed you this on Monday. Just go into Y2 and plug in your asymptote, right? And if I go to Y2 and I don't divide my result of that synthetic division by 2, what if I say 1x minus 5 halves? Come on, Frank, keep up. Now, oh, okay, they're far enough away from it that it ruins my point. But you might be tempted to think, well, it goes down the middle, it never touches it, so it must work, right? Look at the curve of it. Does my graph curl along that asymptote? Or, when I divide everything by 2, getting 1/2 x minus 5/4. Now look at where that is compared to your graph. Skirts right along those asymptotes. That's how you can double check if you did it right or not. Okay? These graphs should curl along the asymptotes. So, this one was 1/2 x minus 5/4. So I go down 5/4, or 1.25-ish. Up 1 over 2 is just in the same weird spot. Why'd you switch colors? Oh, that's right, because I stress it. Up 1 over 2. There we go. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Or down 1 left 2, down 1 left 2, down 1 left 2, down 1 left 2. If I connect those, you curl along the asymptotes. These seem tight enough into those elbows that I'm not going to go find any other points. I think I got it covered. Okay? Now, so far, we have done horizontal at 0, horizontal at A over B. Now we've done oblique. The part that's missing we have not yet done is, what if there's a hole? Okay. If there's a hole. Got to remember we have h of x. Is our brain just hurting? All right. 5 minutes.
My mental acuity is currently negative.
5 minutes.
I get it, Matt.
I'm cool with that. I can use the bathroom too. Okay. 5 minutes, not 7. 5.
I can't walk right now.
Please walk.
What if like all this work just accidentally
What am I?
You can't do that.
Both us.
What if this computer just accidentally
What if this computer just accidentally sets on fire? Like,
just accidentally
it's just like combusts,
accidentally explodes?
just spontaneously combusts real fast.
Got some hairspray and a lighter in my backpack.
Why do you have
Why do you have hairspray?
Why do you think his hairspray is bad?
Hairspray's
How do
not
you
my
think
question.
that happened?
Hairspray's not my question. It's the lighter.
It's concerning.
I do not use hairspray in the morning.
Well, I use it at night.
It's called olive oil.
He uses it with his special hair curlers. He uses it.
Yes.
Oh yeah.
Yes, unlike the old ladies in the 1960s. Got my little hair curlers that I put right here
I
in the
think that
middle.
all comes naturally.
Yes.
Wait, stay there. Put your head there.
You're not right. I'm not No.
It's not gonna get in your hair. Move. Go back.
I don't want to. Get away from me.
Yes.
I'm getting insulted.
It would have been really funny.
Call
It
him
would have traced your head.
rape.
What? Ow.
I feel violated.
What if I just like walk out of the door?
Here's the world today. But you are guys over to the.
You probably wouldn't
I told
notice
him
if any of
to
the
do
girls
it. Well, you
he'd notice if we were down because he'd
Are
be a lot
you
quieter
all
and we were
together
there.
tomorrow, Friday?
19.
In the summer.
Where's the example?
All right. Brain break over. Here we go. All right. Factor, friggin' factor. That's a 4.
Yeah. I almost got it.
See, now it's just ugly. There we go. So, do you remember? Do you remember how I find exactly where the hole is, though? We know -2 is a hole, but -2 what? Yes. If I plug in -2 to what's left, because I'm still going to graph this. It's just that one spot is going to be missing. So plug a -2 in, I get -4 over -6, or 2/3. I plug a -2, 0 of the removed factor, into what's left. Is -4. -2 minus 4 is -6. -4 over -6 reduces to 2/3. Okay? Plug it in. Now you're still going to have all that other stuff. You still have a vertical asymptote at, that wasn't even close. 1, 2, 3, 4. There we go. You're graphing what's left. Okay, so this is now what I'm looking at. There's no asymptote at -2 because that's where I'm going to have a hole. So you graph what remains, vertical asymptote at x equals 4, a x-intercept at +2, a y-intercept at 1/2 and where is my horizontal asymptote? No, not 0. They are equal degrees. So you look at leading coefficients. Leading coefficients are 1 and 1. So I have at y equals 1 a horizontal asymptote. Ha. What you're going to see on your calculator is, remember that when I just have a single pair of asymptotes like this, vertical and horizontal, that they like those L-shaped symmetries? From this intersection, I went left 2, down 1. So I should also be able to go left 1, down 2. I should also be able to go right 2, up 1, or right 1, up 2 from that intersection. Okay, just like a knight can go that was just trash.
Chess has the most players in the 13th and 14th century.
Oh, a knight and chess.
Yeah.
This one.
What else? What did you think? What did you think it was? Like,
I don't
was
even.
it darkness?
Yeah, it's like
Nighttime.
Okay.
Didn't
That
they-
makes so much
Chess?
sense.
Okay. Now, when you graphify in your calculator, this is what you're going to see. This is incorrect. We are missing a piece. Or we filled in a piece, I suppose. I need to put the hole back here at -2 2/3. And then,
But it's kind of weird.
Hold there. Hold there.
hold there.
Hold there.
Okay. So, same stuff we've been doing. It's just when there's a removable factor, you graph whatever's left. Y'all, whatever's left might have an oblique asymptote. It might have 3 vertical asymptotes. Who knows? Okay? Whatever's left, you graph it as normal. You just have to go back and put that hole there. Go.
Oh, now it's over.
Hey, wait, I'm not done.
Sorry. I was learning Spanish. I did it.
Okay. If you didn't have that example completed, you were getting a point. So let's do this.
Wait, what are we doing? Oh,
5A.
Probably the problem on the board.
okay, you know what? 6 full marks.
You're the reason it's all 3 of you. Not just
That's true.
so.
Yeah, but ever since
You wrapped me into this.
no, there's no turning back. You mean 3 of the 4? We have 4? Yes. You. You're not.
assist in your case.
No. One, two, -7. Plug it in. If you are removing -4, plug -4 back into whatever is left, and it'll tell you exactly where I removed it. No, that's your y-intercept.
Yes, Connor. Just yes.
It helps me think.
I know.
I didn't have a.
I'm gonna call cap on
I
that.
didn't have an excuse. I was mopping through the weekend.
I believe the official reasoning is adolescent rectocranial inversion.
Yeah, Jacob.
I'm afraid to ask what that means.
I'm a little bit.
Which part?
What did you take for your wires? Right? Yeah.
Yeah.
Oh, clearly.
It's just. Is that right?
Mhm.
Oh, that's a positive. Yeah, yeah. Okay, I had it as positive too.
Jacob, there's only like 5 minutes.
Um, does everyone get where your now 5 features are coming in? Vertical asymptote, zeros of denominator. Horizontal asymptote depends on degrees and the rules. Y-intercept, plug in 0 or just look at your constant terms. X-intercept, zeros of numerator. And now, whatever removed factor I had, removable discontinuity, gives me a hole. And the hole I find by plugging the removed X value in to find the removed Y value that went with it. because I only have a single set of perpendicular horizontal vertical asymptotes, they're going to have those L-shaped symmetries to them again, where from this intersection, see how I go left 3 and down 3 to get to that y-intercept. So I could also go right 3 and up 3 to make another point. I can go left 9 down 1. I can go right 9 up 1. Likewise, if I can go right 9 up 1, then I can go right 1 up 9. Connect the dots, skip over the hole. You're good to go. Okay? This one a little bit better than those oblique ones we were just doing? Okay. Then when we come back all the way on Monday, we're going to do our rational equations. Those go all the way back to Algebra 1. It's just sometimes we're going to have imaginary zeros or extraneous solutions now. And then we'll move into 2.6, which is calculator mojo. If y'all remember how to do the regression models, we should be able to finish off the back half of 2.5 and all of 2.6 on Monday. And now we will put democracy in action. Do we believe, by referendum vote, that the total nature of this class period equates to a point for the Stooges, or not?
I don't want to miss the Browns or the food. Yeah, don't bring them Tuesday. Yeah.
So, how votes the village? They're fine. They're fine. Or, nah, they get that point. They live to fight another day.
One day.
Yeah, I did.